All right. So it occurred to me we haven't done something that I really wanted to do. So in this class, we learned how to find the slope of a Kirby function, right? That's the first benchmark of calculus. The second benchmark of calculus is to learn how to find the areas underneath Kirby functions. We figured out how to find curve or areas underneath linear functions, right? We just use like triangles, rectangles, trapezoids, stuff like that to find the areas. Okay, but we never really did that in calculus in pre-calc this year, and I feel bad about that. But we got a lot done in not a lot of time, so I think we should pat ourselves on the back for that. We shouldn't break our arm patting ourselves on the back, though, should we? Anyhow, one of the things that we needed to learn in order to be able to learn how to find the area under the curves is something that we call summation notation or sigma notation, and some properties of, and there's a third word, so there's summations, there's sigma notation, there's also series notation. That's what the S stands for. It stands for series, okay? And a series is basically just a, do we know what a sequence is? Don't worry, you guys aren't getting tested on this. But does anybody know what a sequence is? Does anybody see any sequences up here on the board? Is this a sequence right here? Yeah. All sequence is a list of numbers that follows a pattern. What's the pattern to 1, 2, 3, 4? What comes next? 5, 6, 7. The pattern is I take the previous number and I just add 1 to it, right? Okay. Fair, easy enough, right? What do you think these dot, 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 dot mean? To 50?
Whatever.
To infinity. To infinity. What do you think this sum would equal?
Huge number.
So you think it'll go to infinity? Can that go past infinity? Infinity's not a number, right? Infinity's a concept. But I get it, right? It should go on, it should keep growing infinitely, yes? Okay. We're going to see if that's the case. We're going to go through, it's not a terribly rigorous proof, but we're going to go through a proof here to see if this thing does indeed go up to infinity. Okay? And in order to do that, I'm going to need these two guys as well as this one. Okay? We're going to use these three series. Now, this series, the S sub n, is 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8, on and on and on up until infinity, right? This one, S sub g, g is given to the name of the guy who discovered this series. His name was Grandi. He was an Italian monk and a mathematician back in the Renaissance era. But this series is 1 plus a negative 1 plus 1 plus negative 1 plus 1 plus negative 1. What would the next one be? And the one after that? Plus negative 1, okay? That's the Grandi series. And going on for how long? Dot, 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 dot. Forever and ever, right? And then the last one, I don't have a name to attribute this to, so I just called it S sub A. And that is 1 minus 2 plus 3 minus 4 plus 5 minus 6 plus 7. This is where you guys, minus 8 plus 9 minus 10. Going on how long? Dot, 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 to infinity, right? Okay, so the first one we're going to look at, is the Grandi series. I want to see if I can come up with a number that this equals. Who's got an idea as to what it would equal? What do you think, Lyndon? You think it would be 0. And that makes sense because if I use This is all addition, right? And addition has something that we call the associative property, right? Which means I can put brackets in here. I'll do them in red. I can put brackets here, and I can put brackets here, and I can put brackets here, and that bracket is 0, and this bracket is 0, and this bracket is, and 0 plus 0 plus 0 plus 0 plus 0 plus 0. That door's just opened and closed from noise. Nobody touch that. So, does everybody agree this equals 0?
Yes.
Let's try something.
Oh, no.
Hold on. What about if I do this? Yeah, what if I do this? I do -1 plus 1 plus -1 plus 1, and I keep doing that. Then I got 1 plus 0 plus 0 plus, that's 1. Which one is it? I got peanut butter in my chocolate. No, I got chocolate in my peanut butter. So we're going to play with this. And we're going to do something that we call, we're going to do some series math. We're going to manipulate this series. So, S sub G. Remember, that equals 1 plus -1 plus 1 plus -1 plus 1 plus -1 plus ... Right? Now, I'm going to add that to itself. So I'm going to do S sub G plus S sub G. Okay? Now, can I just forego the plus -1 and just write -1?
Yeah.
Is that going to throw anybody for a loop?
No.
You with me on that, Liv? So this is 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus 1 ... minus, right? And now I'm going to, and remember when we did polynomial math, we would add two polynomials and we line the x squareds up with the x squareds vertically, and we line up the x's with the x's vertically, and we line up the singles with the singles vertically, and we'd add them just like we were in elementary school, right? Keeping the x squareds by themselves, keeping the x's by themselves, keeping the singles by themselves. We're going to do the same kind of thing, except I'm going to write, I'm going to write this S sub G in red. And I'm going to add S sub G vertically to this S sub G. And remember, it's in red. But now, instead of writing them lined up perfectly, I'm going to stagger it. I'm going to put that one right there. I'm going to subtract that one right there. I'm going to add this one right here, and minus 1, and plus 1, and minus 1, and plus ... Now, I'm going to add those two together vertically. What do I get when well, first of all, what's this? What's the left side of my equation? 2s sub g. 2s sub g equals. Now, add 1 to nothing, I get 1. -1 plus 1 is plus 1 minus 1. Just zeros all the way across, right? Divide by 2. Divide by 2. And my Grandy series equals 1/2. Okay? I'm going to go to a new page. So this fact we're going to keep in our mind, okay? Now, remember we had S sub A, which equaled, that was the 1 minus 2 plus 1, or no, not plus 1, minus 2 plus 3 minus 4 plus 5 minus 6 plus ... right? That was S sub A. Now, I'm going to take that S sub A and I am going to add S sub A. Okay? So I'm going to do the first one in black, and I'm going to do the second one in red. And I'm going to do the same trick as I did with Grandi series. So I'm going to do 1 minus 2 plus 3 minus 4 plus 5 minus 6 plus dot, dot, dot. And then I'm going to add, I'm going to do this in red. I'm going to do 1. Am I going to do that there? Minus 2 plus 3 minus 4 plus 5 minus dot, dot, dot. Draw my blue line. What do I get on the left side of my equation?
2S sub A.
2S sub A. Very good. And now I get 1 plus 0, which is
1.
negative 2 plus 1, which is minus 1. 3 plus negative 2, which is plus 1. Negative 4 plus 3. Is your mind blown, Lyndon? Minus 1 plus 1 minus 1 plus dot, dot, dot. What is this guy? The Grandi series. That's Grandi series. So 2 S sub A equals S sub G. And I found a value for S sub G, did I not? That equals 1/2. So now, to find what S sub A equals, divide both sides by 2. Dividing by a number, I multiply by the reciprocal, so I get 1/2 times 1/2, and S sub A equals 1/4. Put this down with a dog tag in the back of your mind, because we're going to come back to that. Right? Now, let's go back to the big mama jama. S sub N. What do you think that N means?
Number.
What kind of number?
A real number.
Nah, not quite. They are real numbers, but I can be more descriptive. No, where's there? That doesn't start with N. You're on the right track. It's a set. Which set? What kind of numbers are these? Natural numbers. Okay. Now, I'm going to find out what this is. Okay? So now, what was my trick? It is S sub N, and it was minus S sub A. Was that it? Yeah, I can't believe I forgot how to do this again. And I want to do this. Hold on. I want to do this right. S sub A. And that's going to equal 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus dot, dot, dot. Okay? And I'm going to subtract. Did I do this right? I hope I did this right. Minus, I'm going to do this in blue. And then I want to do S sub A in red. I'm going to put it in parentheses. All right? And remember, what is S sub A?
1/4.
Well, the value is 1/4, but what is the series? It was 1 minus 2 plus 3 minus 4. So I'm going to do this, and this time, I'm going to line this up perfectly. So I'm going to do minus 1, minus 2, plus 3, minus 4, plus 5, minus 6, plus dot, dot, dot. I do have to distribute the negative. Very good, Tyson. So I'm going to distribute the negative. That becomes positive. Boom, 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 boom. So far, so good, right? Now, let's simplify the left-hand side of this equation. What did I say S sub A was worth again? That was 1/4, right? Right, from this last page? S sub A equals 1/4. So S sub A equals 1/4. So this left-hand side of the equation is S sub n minus 1/4, yes? Now, 1 minus 1 is 0. I'm going to write these down individually. 0. 2 plus a positive 2 is
4.
plus 4. 3 plus a negative 3 is
0.
4 plus a positive 4 is
8.
5 plus a negative 5.
0.
This is kind of, I love it when a plan comes together. 6 plus a plus a positive 6, 12. Now, I can simplify this guy, right? Oh, I can't forget the plus dot dot dot, right? Do I need to write the zeros in there?
No.
No. So this equals 4 plus 8 plus 12. What do you think comes after 12? 16 plus 20 plus 24 plus, what is the common factor between all those guys? 4, right? So now I'm going to factor out a 4. 4 times what gets me 4?
1.
Plus 4 times what gets me 8? 4 times what gets me 12? The big reveal's coming, Hallie. The big reveal's coming. 4 times what gets me 16?
4.
What comes next?
6. 7.
What is this guy that I have just put in brackets right here? What is that? That is S sub n, right?
Right, or was I right?
You were right. Now, so now I can simplify this equation. I can say S sub n minus 1/4 equals 4 times what? 4 times S sub n. Subtract my S sub n from both sides. I get how many S sub n's over here?
3.
Equals negative 1/4. 3 times S sub n. And now what? Divide by 3. Divide by 3 is like multiplying by 1/3, right? Times 1/3. And I get negative 1/12 equals S sub n. Now, how many people think this is some esoteric nonsense that I just pulled out of my butt to try and make you guys miserable on your weekend? 2.5, 3, 4.5. Lyndon, we'll call you a half. Well, that'd be 5, right? So half the class thinks I'm trying to make them miserable. Now, Quiz Tuesday. There you go. Now, this is used. That the two things I can think of off the top of my head that this fact is used is in quantum mechanics and in string theory. So 2 fields of physics that this fact is used to prove theories in physics. Now, does that mean that this is not without controversy?
No.
That does not mean it's without controversy. There's a great deal of controversy with this. Because not only is the sum of all natural numbers, according to this, not infinite, it's not even a whole number, is it? How do I add a bunch of whole numbers and get something that's not a whole number?
Yeah.
Not only that, but I add a bunch of positive whole numbers and I get something that's
Bigger than
negative. Negative. Again, negative number. What in the wide world of sports is going on there? Is your brains baking yet?
that. Big.
There, if you go on YouTube and you You search this in YouTube. If you YouTube that, you will see just how much contention there is about this quote unquote fact.